Hey, Andrew. Can we go over 5A and 5B on that 2018? I've been having some. Yeah, absolutely. Let me open it up real quick. Okay. So start with 5A. Make sure you can see. Yeah. All right. That should be good. All right. So 5A. This question says during a chemical reaction, the function models the amount of substance present. The function y equals f of t satisfies a differential equation. All right. So we're given a differential equation. F of t is the solution to that differential equation. First question says use the line tangent to the graph of y equals f of t at t equals 0 to approximate the amount of substance. Okay, so line tangent to f of t. That means we need to find dy of dt. Because dy dt gives us slope of tangent line. And we're given dy dt. It's negative 0.02 y squared. So we need to find specifically at t equals 0. Okay, so this is the big thing. We can kind of think of t as x. Okay, sometimes they use t, sometimes they use x. Regardless of what they use, sorry, this is our independent variable. So this is one we assign. Now, we know what t is, but notice that my derivative has no t's in it. So that's actually really not what I'm concerned about. What I really need to know is, what is y? So when t equals 0, what does y equal? That's what I really need to find. And I can see this. In the question it says, at the start of the reaction, when t equals 0, there are 10 grams of the substance present. So that means at t equals 0, y is representing my substance present. So y should be equal to 10. So in other words, I have dy dt equals negative 0.02 times 10 squared, which equals negative 2. That's great. That helps. That's the slope of the tangent line, but that's not the that we can't use just the slope to approximate the amount of the substance. So in order to approximate the amount of substance, we need to get an equation for the tangent line. So we're going to take y minus 10 is equal to negative 2 times x minus 0, which means y equals 10 minus 2x. At x equals 2, because the question says to approximate the substance remaining at time t equals 2, which we can use as x. If you chose to use t, it's actually probably better. So let's actually do that instead. Instead of an x, let's make that t. Sorry about that. I like that better. So y minus 10 equals negative 2 times t. So y equals 10 minus 2t. At t equals 2, y is approximately 6 grams. So I would just plug in 2 into this. 10 minus 5. 10 minus 4 is 6. So I'm guessing maybe if there was some issues, it might have started with up here. Making sure you get, uniquely, it's usually given to us. We actually kind of had to work to find y. Not really, but we had to look back at the question to find it. So before I go to B, Andrew, let me know, is that good for you? You happy with that? You want me to clear anything up with that, or is that okay? That makes a lot more sense. I tried to take away dy from dt. Okay, yeah, so you got a little ahead of yourself. You overcomplicated a little bit. Just remember, if we want to find a tangent line, if we want to use a tangent line, we just have to get a derivative. Dy dt is the derivative. So they kind of designed this problem to not make you work as hard as it's appeared you needed to. So let's look at 5b then. 5b is a little interesting. There's really not much work involved. Not much I can really do. I'll write down like an explanation, and that's all this question really requires. So it says, using a given differential equation, or using the given differential equation, determine whether the graph of f could resemble the following graph. Okay. Really big thing to notice. This graph they have, that's the graph of f, not of f prime. We're given f prime. So we're going to use that given differential equation. The idea is this. We want to figure out, we don't need to make one, but we kind of want to think of it as like a slope field. Because remember, the slope field should give us a pretty good depiction of what the actual graph would look like. Right, so this has nothing to do with the problem. Don't write this down. Just pay attention. Let me move this up so you can see. If I were to make like a made-up slope field, and I had something like this, we'll do that, I don't know, something like that, and just imagine there's a bunch of other slopes in between there. The idea is the original function is going to follow the slope. Excuse me. So the original function will follow like the slope field directions. So it'll kind of follow that pattern. Same idea here. So basically what we want to figure out is on the interval, not even on the interval, just in general, negative 0.2, negative 0.02, y squared. Okay, now this does have to do with the problem we're doing right now. What is going on with this? What is that telling us? Okay, this tells us the slope at each point. Every single point in the graph, it tells us the slope of the line. So let's pick y values. Okay, what if y is 2? I'm going to have a negative number, right? Because it's going to be 4 times whatever that is, negative. What if y is negative 6? Negative 6 squared is 36 times negative will be negative. The point I'm getting at is no matter what I choose for y, this will always be less than 0 for all y values. So negative 0.02y squared is less than 0 for all y values, correct? So if that's the case, what is that actually saying in the context of the problem? That's saying that my original function should have a decreasing or a negative slope all the time. In other words, f is non-increasing. It's never increasing. The graph of f, that function, will always be decreasing. Look at the graph we're given, though. The graph we're given has an increasing portion. You can see, I'll go to my thing real quick. Look, you can see it's decreasing, 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 and bam, it starts to increase. So that can't be the graph. My original graph should always be decreasing because the slope is always negative, right? So, since this picture has an increasing portion, I guess let me look back at what the actual question was asking. Okay, so since this picture has a increasing portion, it can't represent our graph of f. Something along those lines. Yeah, exactly, Andrew. At the end of the day, it doesn't match. So you don't even need to write all that nonsense. What's really important is make sure you include that first part. Even if you wanted to, you could say it's less than 0 for all y values. If you want to get really specific about it, you could say because y squared will always be positive and negative 0.02 is always obviously negative. Negative times a positive will always be negative. So you can kind of look at it that way too. But the most important thing is that f is not increasing, and our graph does in fact have an increasing portion. So it can't resemble it. All right, so those two problems. Yeah, no problem, Andrew. Absolutely. Anytime. Hey, Kenzie. For 1A, I got 5, so I'm kind of confused on that one. Okay, 1A. I'm guessing you mean 1A for 2018 FRQ. So maybe just clarify that, but I'm pretty sure that's probably what you mean. Yes, okay, cool. Yeah, give me a second. Let me open it up. Okay, so you said you got 5. Oh, all right. So 1A, they give you this. I can actually do that down here. It's not going to take too much space. So they give you this table, and they say for 1A, it says using the data in the table, approximate G prime of 3. All right, so whenever we're given a table and not an equation, if we need to approximate a value, a derivative, we need to take an average rate of change. We don't have the equation, so we can't get like at a specific point. So that means to approximate G prime of 3, we want to take an average rate of change of 2 points, or 2 data points, I guess, that are smushing that. Because remember, a derivative is a slope at a tangent line, so we have to use the slope of a secant line. That's the best way to estimate this, or to approximate it. And so we're going to use 5 and 1. Those are the only 2 closest times we can that split 3, 1 and 5. So we're going to take the average rate of change, or the slope, between G of 5 and G of 1, which is going to be G of 5 minus G of 1 divided by 20.5 minus 15.1. Put that in your calculator, because we have these values. Oh, sorry. Let me rephrase that. G of 5 minus G of 1 divided by 5 minus 1. So y2 minus y1 divided by x2 minus x1. G5 is equal to 20.5. G1 is equal to 15.1. Put that in your calculator and you get 1.35. Does that make sense, Kenzie? Yeah, no problem. And then the last part of that question is using correct units to interpret the meaning. So generally, basically what you're going to say is at time t equals 3, the rate at which grain is being added to the silo is increasing at a rate of 1.35, and your units are going to be feet cubed per minute squared. Because G of t is cubic feet per minute, so G prime of t is cubic feet per minute per minute. No, don't say that, Kenzie. You got a lot of resources. You still got plenty of time. You got a week to still prepare. Make sure you're looking at the feedback on the assignments I'm giving you. I think these are really beneficial. So any feedback I've given you on assignments, take a look back at those. I can tell from your work that I'm looking at, like, there's some stuff that you get really well. So like there's been a couple assignments where you knocked out of the park, you had no problems. And then there's a couple topics where it seems like there's a little bit of a disconnect. Just try to go through the assignments that you did poorly on, and those topics, focus on those. I don't remember any of it, and it's so hard trying to remember from home. Yeah, it makes it a lot harder. I don't think you're giving yourself enough credit though. I know you remember some of it. I think it's just the key is going back and reviewing, just to like spark the memory again. Because it's like some of the stuff we haven't seen in a long time. So now that we're doing all this, we've been doing this review for like the last month or whatever. It's all kind of flowing back, and it all kind of seeps back into your memory. So that's why I just practice it. Make sure you're doing practice problems and questions that AP offers, and you're doing these assignments. That's going to help. Yep, no problem, Kenzie. Hope you have a great rest of your day. Hey Emma, can you explain 5A, 5B, and 6D to me? I think I'm doing what I'm supposed to. Yeah, sure thing. I actually, tell you what, I went over 5A and 5B, so I'm just gonna, I have the work already up. I'll go through the work with you. I did that with Andrew. It's funny, you and Andrew always seem to have the same questions. You guys should coordinate to come in at the same time for the office hours. All right, so I guess I can go down a little bit. Let's start with 5A. Okay, so here's the situation for 5A. Let me open up the question. It gives us dy dt. So it says that f of t is a solution to our differential equation, negative 0.02 y squared. Okay, so the first question says use the line tangent to the graph of y equals f of t at t equals 0 to approximate at t equals 2. So what we need to do then is we need to first, if we're using a line tangent to the graph, we need to get an equation for a tangent line. So in order to get an equation for a tangent line, we need the slope of the tangent line and the points on the tangent line. So we start with that. First of all, to get the slope, that's dy dt. Right? A derivative gives us slope of a tangent line. So we take our equation, dy dt equals 0.02 y squared. And we want to find out what the slope is at t equals 0. So you can see that's where I wrote right here, at t equals 0. Now my question is, though, what is my y value? Because if I plug in t equals 0, there is no t here. So that's not doing me any good, right? I need to get rid of this y. I need to get a number. A slope is a value. So I have to find y. Well, I get y equals 10 because the original question says that. It says at the start of the reaction, t equals 0, there are 10 grams of the substance. Y is the representative of this amount of substance. So that means that y equals 10. So at t equals 0, y is 10. So I plug in 10 for y, and I get negative 0.02 times 10 squared, which gives me negative 2. All right, so negative 2 is my slope of the tangent line. But I want to get the equation of the tangent line. So I take my 0.010, I do y minus 10 equals negative 2 times t minus 0. Add 10 to both sides, distribute the negative 2, and I get y equals 10 minus 2t. Plug in t equals 2, right? Because the question didn't ask for at t equals 0. It says use that line tangent at t equals 0 to approximate at t equals 2. So we plug in t equals 2 in for t, I should say, and you get 6 grams. I know it was quick, kind of flew through that, Emma. Let me know, before I move on, is 5A okay for you? Did that stuff make sense? That makes sense. Okay, cool. So let's look at 5B. Move this up a little bit. All right, so 5B, they give us this graph of f. So we have a graph of f. Now the question is our given differential equation, or based off our given differential equation, could that be a graph of f? Does that make sense? So that's what we have to determine. And to determine that, we got to think of kind of along the lines of a slope field. Remember, I drew a little picture for Andrew. It looks a little bit different for you. We have a slope field that's giving us a sketch, basically, of the original function. Based off a slope field, we can sketch what we think the original function would look like, because a slope field is giving us the slopes at a bunch of different points. So I gave him an example here. Like it looks like the slopes would be trending up at my original function. So what we want to determine is what would the slope field look like for this kind of a function based off our differential equation. And we're given the differential equation negative 0.02 times y squared. This is the most important part of this question, is that's always going to be less than 0. And here's why. Because no matter what y is, I don't care if it's positive or negative number, when you square it, it turns positive. So I'll always have a negative times a positive will give me a negative number. So that means what this says, this statement here, this is saying that the slope of the original function f at every single point is going to be a negative slope, meaning it's going to be decreasing all the time. The graph of f should always be decreasing. In other words, f is non-increasing. Well, look at the graph they gave us. That graph is increasing. there's a point in that graph where it like goes down, but then it slowly starts coming back up. So just simply based off of that fact that f can't be increasing at any point, and that graph does, that graph cannot resemble the correct f. And let me know if that makes sense as well before I move on to 6. Okay, looks like you're good. All right, so let's look at 6D. So the question says, let y equal f of x be a function defined implicitly by that, that is continuous on the closed interval 2 to 2.1 and differentiable on the open interval 2 to 2.1. Use the mean value theorem on the interval 2 to 2.1 to show that 1 to 15 is less than or equal to blah, blah. Okay, so first and foremost, let's actually write down the mean value theorem, what this is basically saying. What this is saying is that f prime of 1 is going to be equal to, or sorry, f prime of c, not 1, f prime of c is going to be equal to f of 2.1 minus f of 2 divided by 2.1 minus 2. Meaning the tangent line at some point c that we don't know is going to be equal to the secant line of the interval, which is 2 to 2.1. Okay, that's essentially what we're looking for, but let's just focus strictly on this. Okay, actually, no, let me take that back. Let's just look at, in general, the whole thing. F prime of c. What do we know has to be true about the derivative for any point? And to find that, you have to look back at the original question. I'm sorry, I don't know if you can see. Let me put on a light. I apologize. I didn't realize that. Okay, that's better. So f prime of c equals f of 2.1. Yeah, sorry, Haver. I just saw that. So this is kind of just the general mean value theorem, just the setup. What do we know as f prime of c? Well, to find out what we know about f prime of c, we have to look back at the original question. It says consider the curve, blah, blah, blah. For all points on the curve, the derivative is less than or equal to 2. So f prime of c will be less than or equal to 2 and greater than or equal to, 2/3. Okay, so since they give that to us, we can create this, this range. We know that at any point, it doesn't matter what c is, any point, it has to be between 2 and 2/3. Which means that 2/3 has to be less than or equal to the right side of this equation, right? If f prime of c equals that, then the 2/3 has to be less than or equal to f of 2.1 minus f of 2 divided by 2.1 minus 2, which has to be less than or equal to 2. This step I probably should have done earlier. Just makes our lives a little bit easier. 2.1 minus 2 is 0.1. And then I can multiply everything by 0.1 to get rid of that fraction, which leaves me 1/15 is less than or equal to f of 2.1 minus f of 2, which is less than or equal to 1/5. And that's what the question asked us to prove. So I think the hardest part of this question was this right here. I have a feeling that you probably got something similar to this up here, hopefully, which would be awesome. If you got there, which is great. To get this, you have to just, it doesn't take any math or any sort of crazy formula. It's literally just look back at the original question. Like I said in class today, Haber, they're never going to give you something you're not going to use. They're not going to give you useless information. Every single word they say is useful. Which means you get to part D and you notice that this first portion, sorry, let me just show my screen. If you get to part D and you notice that this portion was never even discussed, never mentioned, never even looked at, that's a huge hint to say, okay, I got to use it. It wasn't given to me for no reason. I have to use it. So let me see if somehow I can work that into this question. That's kind of the mindset you want to take. Okay, I didn't think I used that interval since it wasn't in the interval of 2 to 2 and 1, but that makes more sense. Yeah, so the key thing is that the interval they talked about there, the 2 to 2.1, they're talking about f of x, right? That's the interval of f of x. But in that interval, we're focused on dy dx. So we're not really too concerned about the mean value theorem is just approximating this c value. So that's all the information we have. That's what we got to use. Yeah, no problem here. Have a great rest of your day.